Dear 12th standard students, in previous video class, you learnt about mirror equation and lateral magnification and some problems. But now in this video session, we will discuss about speed of light. Already you know about what is light. Light is an electromagnetic radiation. It will traverse with the speed, maximum speed or highest speed in vacuum 3 into 10 power 8 meter per second. It is denoted by the symbol C. Its value 3 into 10 power 8 meter per second. So, several attempts were made by scientists to determine the speed of light in air. Among these, earliest attempt was made by French scientist Hippolyte Fiso. He was determined the speed of light in air is almost close value or almost actual value of speed of light in air. Now we are going to see about Fiso method to determine the speed of light. Initially, we are going to see about apparatus construction to determine the Fiso method to determine the speed of light. It is a simple apparatus. It was used by the Fiso to determine the speed of light in air. See, it consists of source of light and partially silvered glass plate. It is partially silvered glass plate, and this apparatus consists of rotating toothed wheel. This rotating toothed wheel consists of n cuts. This is one of the cut. It is another cut. It is another cut. So this kind of, it consists of rotating toothed wheel consists of n number of cuts, and also it consists of n number of teeth. It is one of the teeth. It is another teeth. So therefore rotating toothed wheel, it consists of n number of cuts and also n number of teeth. This rotating toothed wheel can be, that the speed of the rotating toothed wheel can be altered by external mechanism like electric motor. Then it consists of perfectly reflecting mirror. So this is a simple apparatus construction. It was used by the Fiso to determine the speed of light in air. So keep it in your mind. Source of light, partially silvered glass plate. So partially silvered glass plate which is kept 45-degree angle to the incident light. Another one, rotating toothed wheel. That rotating toothed wheel consists of n number of cuts. It is one of the cut like this. It consists of n number of cuts and also it consists of n number of teeth. Another one, it consists of perfectly reflecting mirror. Next, this apparatus was used by the Fiso. How to determine the speed of light? See, it is a source of light. Light coming from the source is allowed to fall on a partially silvered glass plate. Then light is reflected by the partially silvered glass plate is allowed to make to fall on a rotating toothed wheel. So it was initially at rest. It will not rotate. So rotating toothed wheel, initially it was at rest position. So therefore light coming from the source is allowed to fall on a partially silvered glass plate which is kept 45-degree to the incident light. Then reflected light from the partially silvered glass plate, it was made to allowed to fall on a rotating toothed wheel. It was initially at rest position. Then the light is reflected light from the partially silvered glass plate is made to pass through the one of the cut in the rotating toothed wheel. See, it is the one of the cut in the rotating toothed wheel. Then the light come out from the one of the cut in the rotating toothed wheel is allowed to fall on a perfectly reflecting mirror. Then perfectly reflecting mirror is reflects the light, perfectly reflects the light, then reflected light is returned back to the same way and returned back to the made to fall on a with the same cut, then the made to fall on a partially silvered glass plate, then the reflected light is made to pass through the partially silvered glass plate, reaches the eyes in the observer. This initial one. So initially, then the rotating toothed wheel will not rotate. It is a rest position. Then light reflected by the partially silvered glass plate, it was allowed to fall on a one of the cut in the rotating toothed wheel. Then light is made to fall on a perfectly reflecting mirror. Then light is perfectly reflected by the reflecting mirror is made to passing through the with the same cut in the rotating toothed wheel, then made to passing through the partially silvered glass plate, then the light is reaches by the eyes in the observer. It is the initial work. The next, Fiso to increasing the angular velocity of the rotating toothed wheel from 0 to omega value. Omega is the angular speed of the rotating toothed wheel. So Fiso, he was initially increasing the angular velocity of the rotating toothed wheel from 0 to omega value until then light is made to pass through the one of the cut is blocked by the adjacent cut. That is the angular velocity of the rotating toothed wheel. So very important one. Omega is the angular velocity of the rotating toothed wheel. It will increases from 0 value to omega until light is passing through the one of the cut is blocked by the adjacent tooth. That is the omega. Then already we know that speed of light. Speed of light which is equal to total distance traveled by light divided by time taken. So this is a general expression, speed of light which is equal to the ratio of total distance traveled by the light divided by time taken. Here the distance between rotating toothed wheel and the perfectly reflecting mirror is small d, which is equal to 8 kilometer. It is known value. Fiso was increases angular speed of the rotating wheel from 0 to omega value, which is light travel from the one of the cut and the light is blocked by the adjacent teeth. So therefore, the distance traveled by the light d is the light passing through the one of the cut to reaches the perfectly reflecting mirror. That value is d, which is equal to 8 kilometer. But the light traveling from the one of the cut and travel a d distance gets perfectly reflected by the reflecting mirror and travel with the same d distance. So total distance traveled by the light when light passing through the one of the cut and the light is blocked by the adjacent teeth, then the total distance traveled by the light is 2d. It will take in a time t, it is the speed of light. It is equation number 1. Then omega is the angular speed of the rotating toothed wheel. How we calculate the angular speed of the rotating toothed wheel? Light is coming from the source, then allowed to fall on a perfectly silvered glass plate. Then the partially reflected light is traveled through the rotating toothed wheel. Then the light is passing through the one of the cut and travel a d distance, gets perfectly reflected by the perfectly reflecting mirror and blocked by the adjacent tooth. It will travel a distance 2d. At that moment, angular speed of the rotating toothed wheel is omega. So omega, which is equal to theta divided by t. Here theta is the angle between one of the tooth and one of the cut. It is the theta value. So theta is the angle between one of the tooth and one of the cut. That is the adjacent cut. That is theta value. T is the time taken by the light to travel through the one of the cut, to travel a d distance and perfectly reflected by the reflecting mirror after reflection to blocked by the adjacent teeth. That is a time t. This is equation number 2. So omega, which is equal to theta divided by t. So equation number 2. Then how to calculate the theta value? So theta, which is equal to total angle in the rotating toothed wheel. So this is the rotating toothed wheel. Total angle is 360 divided by n number of teeth plus n number of cuts. So theta, which is equal to total angle 360 divided by n teeth plus n cuts. So therefore 2n. So theta, which is equal to 360 degree, which is equal to 2 pi radian. 2 pi divided by 2n. 2 get cancelled. Theta, which is equal to pi divided by n. Equation number 3. So equation 3, substitute in equation 2. Equation 3, substitute in equation 2. Equation 2, angular speed of the rotating toothed wheel, omega, which is equal to theta value pi divided by n divided by t. So angular speed of the rotating toothed wheel, which is equal to pi divided by nt. Equation number 4. Then we are going to calculate the speed of light in R v, which is equal to 2d divided by t. So before going to calculate speed of light in R, first we want to calculate the time. So therefore from this equation, time t, which is equal to pi divided by omega n. So substitute here speed of light in R v, which is equal to 2d divided by t value pi divided by omega n. So speed of light in R was determined by the Fiso 2d omega n divided by pi. So d is the distance between rotating toothed wheel and the perfectly reflecting mirror. Omega is the angular speed of the rotating toothed wheel. N is the number of cuts, which is equal to number of teeth. Pi is a constant value. Dear students, Fiso was determined speed of light in air on the basis of equation V is equal to 2d omega n divided by pi. But Fiso had some practical difficulty to visually estimate the minimum intensity of light coming from the partially silvered mirror, and he gave the value of speed of light in air very much close to that of actual value of speed of light. But later on, many scientists determined the speed of light in air on the basis of Fiso's idea and determined the perfect value of speed of light in air. Speed of light in air, which is equal to 2.99792 into 10 power 8 meter per second. Thank you, students.